on the topic of naming compounds, this is where having memorized your symbols is really going to be paying off. We're going to be forming compounds, which is putting symbols together for individual elements. And you're going to have timed quizzes, you're going to have timed tests, so it's going to be very beneficial to you to remember what those symbols are. And again, if you don't remember them or you need to review them, go through flashcards, make flashcards if you haven't, and memorize them because it's going to be extremely helpful. All right, so you have a study packet where we had this flow chart here. We're going to be using the one that I gave you that is blank. So that should be in your glued into your spiral. We glued it in class. If you're absent, I'll put it up on the website. You can download it. But I specifically gutted this out so that you could write it in on your own. You remember it better if you do it that way than if you just read what's already written on the page in front of you. So just looking at ionic compounds, that's what we're going to start with first, is ionic compounds. So I have, for this one, I have whited out everything else so that we just have what we're looking for. Also remember that when you glue these in, if you will fold a tab down on that paper so that you still have lined space in your journals to make notes on, that would be perfect. So naming compounds, what is it made of? Metal and a nonmetal. This is the first question we should always be asking, what's it made of? And if it's a metal and a nonmetal, then you know it's going to be an ionic compound. And remember that the way to tell whether it's a metal or a nonmetal is by looking at the periodic table. Anything to the left of the stair step, everything that is blue is a metal. Everything to the right is a nonmetal. These things on the stair step, they are metalloids. However, if something is to the left of the stair step, we're going to lump it in as a metal. If something is to the right of the stair step, even if it's touching it, we're going to lump it in as a nonmetal for purposes of compound name writing. Okay, so now let's look at what we should be writing in. Pause the video as you need to fill in your notes, but we should be writing in metal and nonmetal. Main question, what's it made of? If it's a metal and a nonmetal, it's an ionic compound. What should we be writing at this point? That we use "ide" in the ending and no prefixes. No prefixes. It's not hard for you to remember now because we haven't introduced the concept of prefixes, but once we do, it tends to be confusing. So just remember, no prefixes. They're in bold. So then the other thing we do, just to name them, it's actually really easy. We just name the metal and then name the nonmetal. And just make sure that the ending is "ide", "ide" ending. That's it. So the first example they give you is lithium sulfide. Here it's just Li and S. It doesn't matter how many there are. Here it says that there are 2 lithium, but you know what? It doesn't really matter. If I look on the periodic table, lithium is right here. It's to the left of the stair step. It's a metal. So I really don't even have to look at what the next thing is, because if it starts with a metal, then I know it's going to be a metal and a nonmetal. So that's going to be ionic. So then I just name the ions. The first one is just lithium. The next one would be sulfur. We should have that memorized, but remember that we're changing the ending "ide." So it becomes lithium sulfide. And there's your answer, lithium sulfide. All right, and that's all we have to write in that box for now. It's Li2, Li2S, lithium sulfide. And that's all we need there. Let me give you some other examples. And on your notes, you should have that printout that has a space for notes at the bottom. So or space for examples, right? You've got that bottom space for examples. So let's go ahead and write some right there. So let me see. Let's move that up there so that we can be looking at it. Let me delete that. Let's say, first example, I'm not even going to say it. Sorry, I was almost going to give it to you. Mg and, oh, here's number 1. Pause the video as we go through these. Pause before you go over the answer so that you're thinking through it yourself. If you're just watching and you're just copying down the answer and you're not trying to guess it beforehand, you're not really getting a whole lot out of this. Okay, so this, I should have memorized, is magnesium. Magnesium. This is oxygen, but we are changing the ending, so it's magnesium oxide. And that's the name. All right, let's start another one. Let's do this and this. Okay, so now, again, I should have memorized Al is aluminum. And what is it made of? Well, aluminum here is a metal. So that means it's going to be ionic. And then if I check for chlorine, sure enough, it's right there. Metal, non-metal. So I just named the ions. There's aluminum. And chlorine becomes, let's add that ending, chloride. And that's it. Here are 3 more. Go ahead and pause the video and try and answer these. And then check your answer. Example number 3, I'm looking at Ca, calcium. Calcium is here. It's a metal, so it's ionic. I just named the ions. Calcium, and instead of fluorine, I changed the ending to ide, fluoride. All right, try the next one. So the 4th one, we always, when we are trying to name, look for that element on the periodic table. Potassium is in the alkali metals. So it is a metal. It's to the left of the stair step. So I named the ions, potassium, and then phosphorus, but we're going to change the ending, so it's phosphide. If you put phosphoride, you're still following the naming rules. It wouldn't be counted wrong, but just know that by convention we shorten it and we just say phosphide. All right, now number 5. Number 5 is barium nitride. Again, this is a metal. It's to the left of the stair step. This is a nonmetal. Nitrogen is to the right of the stair step right here. And so if you said barium nitride, again, it would still be right, but just know that by convention we shorten that to nitride. This is really important to remember going forward because we often hear about nitrate. Nitrate has a different ending. It's a different type of ion. When we just see nitrogen by itself, that is nitride. We just put an ide ending on it. That's it. Barium nitride. We just name the ions for ionic compounds. Covalent compounds are a little bit different. Remember that covalent compounds are made up of 2 nonmetals. So fill that in on your table. 2 nonmetals. This is what makes it a covalent compound. So instead of getting rid of or accepting electrons in order to make a full outer shell, these atoms will share. Like this hydrogen, this is the hydrogen's 1 electron. It is sharing one of oxygen's 6 electrons so that it has a full outer shell, and it only needs 2 because it's really small. Same thing with this hydrogen. Oxygen is a little bit bigger. It needs 8. It has its 6, these blue, and then it shares one with this hydrogen. It shares one with that hydrogen. And they're all happy. They're cooperating and sharing. Okay, so a difference in covalent compounds, here you do use Greek prefixes. Don't try to use the prefixes with ionic. This is only for covalent. We put prefixes in front of the element names to say how many there are. The only exception to that is we don't use mono for the first name. We can use it for the second name, but we just don't use mono for the first name. It's, again, just a convention, just to make things, I don't know. So an example here, N2O4. Well, the first thing I need to do is I need to look on my periodic table and see where this guy is here. Nitrogen is here. It's to the right of the stair step. So right off the bat, I'm starting off with something that is a nonmetal. So that tells me if it's a nonmetal, this other one's going to be a nonmetal, this is going to be covalent. So now I'm going to use my prefixes. So there's 2 nitrogen. So I would write dinitrogen to show that there are 2. And then for 4 oxygen, tetra means 4, so it would be tetroxide. Okay, so a couple things we need to know to be able to do this at this point, and that is we need to know what these prefixes are. So take a moment on your lined paper in your journal, write these down. Yes, I know that they might be printed for you somewhere else, but remember that if you are physically writing these yourself, you're going to remember more. So in that lined space, I know it seems redundant, write it down. 1 mono, 2 di, 3 tri, 4 tetra, 5 penta, 6 hexa, 7 hepta, 8 octa, 9 nona, 10 deca. Okay, so now let's use these. On the back of your paper, in fact, let me keep that here. On the back of this paper that you have glued in, you have a space over here that looks just like this, but without the answers. We're going to fill in those answers. So use that space right now. I am going to move that so that we can see what's going on there. So the first one, let me show you. We have 1 nitrogen. We have 1 oxygen. We don't use mono on the first element, but we will use mono on the second one. So this is just going to be nitrogen monoxide. Pause the video, see if you can do the next 2. Okay, so let's look over the answer. NO2 would be nitrogen dioxide. The next one has 2 nitrogen, so that's dinitrogen, and then it's trioxide because there are 3 oxygens. Pause the video and try the others, and then I'll give you the answers. Okay, so dinitrogen tetraoxide, dinitrogen pentaoxide, sulfur hexafluoride, iodine heptafluoride, tetraphosphorus. I don't know why it's shortened. I would write the whole thing there. Tetraphosphorus, decaoxide. You also notice that you can drop the A and just say decoxide instead of the A oxide, and that's okay. Either way is acceptable. P4S9 is tetraphosphorus nonasulfide, and then this one is tetraarsenic decaoxide. It's supposed to be AS for arsenic. There's kind of a typo on there. That's supposed to be a lowercase s, but tetraarsenic decaoxide. And so that is how you name covalent compounds. As we look at the last part, they're still ionic compounds. They just look a little bit more complicated because there are 3 or more elements. They're polyatomic, but these are still ionic compounds. So we follow the same rules where we just name the ions. The only difference is when we start with our metal, that's going to be easy enough, but we're not going to have the anion be one of these. We're actually going to have the anion be something from your polyatomic ions chart here. And I don't really like the way that the state has this, because if you see, it seems like that 2 and 3 are on top of each other, and so we tend to get confused with that. I know this is what you're going to be using on your test, and that's fine, but I also want you to get used to seeing it a different way that might be a little clearer, and that's why I have this in your notes as well. So we can use this to name some examples. I'm going to write some examples down. I want you to try them, and then you can check the answer. Okay, so try these, 6, 7, and 8. And remember that it doesn't matter how many we have of the ion, we just name the ion. Here we've got 2 of this guy here, but it doesn't matter. Just name what you see. Pause the video. Here are your answers. I hope you got really close. We'll be practicing and working with these more in class.